Hello and welcome to this CS50 seminar, which is JavaScript the Basics. So quick introduction, I am Sela, junior studying computer science, and we'll be going through the basics of JavaScript. So in this case, we're going to go over the different data types that we have, some functions, some looping, constructs, and then we'll also go through JavaScript's asynchronous nature. Right, so look at callbacks, promises, async await, and so we can dive into the seminar. Okay, so we'll start with basic introduction to JavaScript, which is what is JavaScript and what can you do with it. So JavaScript, in a nutshell, is a programming language, right? And then some of the terms that you hear whenever people are talking about JavaScript is it's single-threaded, it's asynchronous. So I won't dive into these terms right now, but we'll come back to them, right? And so a brief history on JavaScript is JavaScript was originally built to run in the browser. And so browsers come embedded with JavaScript engines. And then JavaScript engines in this case are responsible for executing JavaScript code. So some examples are SpiderMonkey in Firefox, and then the V8 engine in Chrome, right? But then sometime later on, some brilliant engineer came along and then decided to embed Chrome's V8 engine into some C++ program. And then he called this framework Node, which is Nodejs. And so what this Nodejs framework enables us to do is it enables us to execute JavaScript code outside the browser. And so with us getting this capability to execute JavaScript code outside the browser, that meant we could now write server-side JavaScript, right? We could build entire web applications solely in JavaScript because we can now write our backend in JavaScript and simply run our JavaScript in the Node.js framework. Okay, so that's kind of like a brief history in JavaScript. And so now we're going to dive into working with JavaScript in the browser. So we'll go over, so I'm going to open a browser terminal. So I'm going to open a browser window, and then in this browser window, I want us to go over working with JavaScript in the browser, right? So like I mentioned, Chrome has a V8 engine, which is responsible for executing JavaScript code. So if you open up Chrome, right, so in this case, I'm using the Chrome browser. So I'll show you how it got here. So you can literally open up the inspect. Sorry, wrong click. OK, so you can literally open up the inspect option. And so this brings us a bunch of options. And then because we're dealing with JavaScript, what we're concerned about is the console. So the console is where we can write random JavaScript code and execute it and see what happens. So JavaScript is, like I mentioned, a programming language. So it comes with like its basic data types, such as numeric data types. So you can have something like 5, right? And you can store this in a variable. So I've looked at variables previously. So say I said x equals 9, and I can say y equals 10. And I can do basic mathematical operations with it, which is, so in this case, I just executed x times y, which gives me 90, right? And then we could also have string types, right? So let's say I had a name, right? So in this case, my name is Sela, right? And I can store that. And one function that we're going to consistently use when using JavaScript is a console.log. And what console.log does is it simply prints out something to the console, right? So in this case, if I wanted to print out my name, I can simply print out console.log name. OK, so in the console, you can also execute some basic JavaScript functions. So one function you've probably encountered is the alert, right? And then, so alert is meant to pop up some window. So if I run this, so we do see a window pop up there. It says greetings. And I could do something, right? So let's say I just didn't want to say greetings, and I actually wanted to say greetings to Sela, right? So I can use the plus sign, which really just concatenates some strings. So in this case, I have the greeting string, and I have the name string. And I can execute the two together, and I get greetings Sela. And then one other nice feature that you can probably relate to with Python is, as opposed to me using this plus sign to concatenate my strings, I can actually format my string to have the value that I want it to have. So in this case, we're looking at greetings, right? And then I want it to have Sela in it, right? So I have greetings, then I can use the $sign with the curly braces and have the name, which I want to input there, and then close. And then when I execute that, I still get the same thing that I had. So greetings plus name is the same as me having greetings, $sign, open curly braces, the value that I want to have, close curly braces. And then one other thing that also changed is, instead of me using the quotation marks, the quotes, I'm now using the backtick. So you can find the backtick right before 1 on your keyboard if it's a Mac keyboard. Not sure about the Windows keyboard. But yeah, so anyway. So these are some basic things we can do in the JavaScript console. And so we can also go over to an actual script and see how we can execute JavaScript code from there. So I'm going to open up an HTML page. Sorry, give me a moment. OK. OK, so so here I want us to go over some other data types that we have in JavaScript. So we looked at numeric data types, we looked at strings. So one other important data type that I think you need to know for JavaScript is the object data type. So an object, really, you can think about it as something that has properties and methods. And then in here, I have created a bunch of objects in which I have listed some key value pairs, right? So if familiar with Python, this kind of looks similar to the dict data type, where you can assign values to keys. So in this case, I have a list of students, right? And then for each student, I have different properties, which is I have a name, I have a house, I have a major, and then I have a number of students in there. And then we could also, so we could go over creating an object in JavaScript. So let's say I decided to create a new student object. And then I'll say let new student equals to open, close curly braces, right? So similar to how you initialize a dict in Python. And then I can assign values and properties to this new object. So I can say I want my new student to have a name of, say, John. And then I can say let my new student be a member of the house. I'll say cupboard again. And then I can say let my new student be a mechanical engineering major. Right? So I have now created a new student, right? And then we can, so I can console.log this student. OK. And so if I opened up my browser, OK, so I have this JavaScript that I have defined, which I have written out. And then this JavaScript, I have included it in this HTML page, which is just basics. So I have this particular page open here, right? And then if you notice, on this particular page, I also have the console window open. And if I had to refresh this page, I have my new student that's here. And OK, so I'm actually printing out the student itself. OK. So if I look at this, so I have a new student who I am console.login. So I said my new student is going to have a name Joan, house cupboard, major ME, and then we see that happen there. And I'm also printing out all the students that I have. So my students array has the predefined students that I made. And then we see the predefined students in there. And so if I wanted to add this to my array, I can simply say, in my students, I am going to push my new student. So if we have this, so we notice our array now changes. Instead of me only having 2 objects in my array, I now have 3 objects with all of them in there. Okay. So now let's say I didn't want to print out all of this. Let's say I wanted to go over all my students, iterate through all of them. So in this case, I want to loop over my students and maybe print out a particular value from my students. So we can, of course, use a for loop. And then, so we're familiar with for loops, and I'll probably use a different one that we haven't used so much, where we can have students, and then students, I can, on students, call the loop for each. So what students.forEach does is it's going to go through every student and then return the current student that I'm at. So in this case, return the current object that I'm at in my array. And then for this object that I'm returning, I'm going to define a function which takes in, so I'll say student, where student is the current student I'm looking at, and then does something with the students, right? So let's say all I want to do is just print out the names of my students. So I'm going to say student.name, console.log student.name. And then if we save this, we notice in our browser window, I print out all my student names, Sela, Jobin, John. So what students.forEach did is, so it goes over, like I said, so it's going to iterate over all my students. And then it's going to return every single item that's in my student array. So in this case, every item in my student array is an object, right? So let me show you that. So we can print out the student itself. And if I save this, so you notice student is actually an object. Then I can do anything I want with that current item I'm at in the array. Or I have that. So what I have inside my .forEach is this function here. So this function is a function that's called each time I go to the next item in my array. And then we can use some nice JavaScript syntax to actually make this more concise. So notice here I have function defined, but then I have no name, right? So basic construct for a function in JavaScript is you declare that I'm beginning a function, then you put some name, and then some arguments, parentheses in your brackets, and then have the curly braces. But then in JavaScript, we are not mandated to actually provide a function its name, right? So in this case, I can do away with the func name and then just have a function. So in this case, this is an anonymous function because I really haven't given it a name. So what I have inside here, inside my forEach, is an anonymous function, right? Now, in this case, I have an anonymous function. So with later versions of JavaScript, they decided, well, I'm not giving this function a name, right? I might as well just not have it there. So then they introduced another syntax, which is the fat arrow, where I do away with the function, and then instead of me having function student, I just do student, which is the parameter, the argument that I'm passing in, which I was going to pass into my function, and then have this fat arrow. So we notice if we run this code, it still does the same thing, right? So it's just more concise, and you'll probably come across this notation, this type of syntax from time and again. And so they just didn't end there, and they went further, right? And then they said, well, I have a function, and so my function takes in one argument, which is student, and it simply has one, it just returns one thing, right? And the only thing it returns right now is just console.logs, in this case, prints out a name. So they said, I as well don't need to have my curly braces here, right? And so I can just do away with them. And if I run that, So notice it still does the same thing, right? So the function that we had before has just really just like been shrinked, and then now I have this more concise function. Okay, so that's on our objects and functions and some function syntax. Okay. Okay, so we're now going to move on to JavaScript and the DOM, right? So we've gone over some basic constructs in JavaScript, and so now we have to look. Now I want us to look at using JavaScript on the client side, right? Which is really using just JavaScript to manipulate the DOM. So I mentioned earlier that JavaScript was initially built to run in browsers, right? And then what JavaScript did for us and still does for us with it being able to run in browsers is I can actually add some dynamic functionality to the different HTML pages that I have in my browser. Now, the question is, how does JavaScript manipulate? So it's a programming language that's going to work with the different elements you have in your browser. So in this case, an HTML page. So the question is, how does JavaScript actually manage to help us manipulate our HTML pages? So in understanding that, we come across the DOM, right? So the question is, what is a DOM? So to put it simple, the DOM is a programming interface for HTML and XML documents. So what does that mean? So the DOM is simply that it's an object that enables other programming languages to interact with my HTML or XML documents. So in this case, we'll be focusing mainly on HTML documents, right? And so what the DOM does is it takes an HTML page, represents it as a single object in a universal format such that any programming language that I wanted to use that provides that interface with DOM objects can use it to manipulate the DOM. Okay, so with recent lectures, so we've been looking at working in the web, building web applications, working in JavaScript. So we're just going to quickly go over some of the methods that we've encountered with using JavaScript to access and manipulate the DOM. So I singled out some. So in this case, we have document.getElement by ID, which has been in use for quite a while. And then document.querySelector, document.querySelector are really some methods which are added later on, right? So maybe not as popular, but still very useful. And I will show you how you can, we'll go through examples of how you can use them. Like say, how can I use document.querySelector in place of document.getElement by ID, right? So let's go. So open up some code examples again. So, and then we'll go through that. Okay. Okay, so now I have a new HTML page, which is, so I have it open here also. So this is my DOM page. It really just has one header tag, one h1 tag. And in this HTML page, I have linked another JavaScript file. So, sorry, that's the wrong one. Okay. So presently, my JavaScript file is empty, right? And then, so we're going to populate it with some basic JavaScript things we can do with the DOM. So, like I said, so let me close this one. We don't need this. Okay, so like I said, JavaScript is able to access and manipulate DOM elements. And so we'll start off with something basic that you can do with the DOM, right? So you only have one tag in here, one header tag, which is my DOM page. And let's say you actually wanted to create a new element in your DOM and then add it to your DOM and have it displayed. So of course, the simple way to do this is you could just literally go into your HTML page and say, I am going to add, so I need to add a paragraph. I'm going to add a paragraph with some stuff, right? But then when you start programming, you probably find that some things that you add to your page are not needed when your page is actually loading, but then you probably want to provide that information after your page is loaded and you've maybe gotten some information from a user, right? So let's see how we can add a simple paragraph in my HTML page. Okay, so let's start with let p equals. So I'm going to use my document object, which provides me some methods that I can use to achieve what I want. So in this case, all I want to do is to create an element. So I'm going to create an element, and in this case, I want to create a paragraph. So it's going to be a p element. And then to my paragraph, I can add some content, right? And so let's say let p dot text content equals, let's say CS50 is awesome. And then, so I've created an element, which is a paragraph. I've added some content to my paragraph. And now I actually want to stitch this element that I've added to this document that I have, right? So in this case, I'm going to call my document object again, and then say from my document in here, I want to get the body. And then to my body, I want to append some child, right? So in this case, the child I want to append is a new paragraph element that I've created, right? So I can save this and see what happens. OK, so right now I'm in my console. So if you had your element, right, so we notice my paragraph, which is supposed to CS50 awesome, hasn't been added. And one useful debugging tool I like using when I'm using JavaScript is use the console, right? So the console is going to tell you, so you have some error, cannot read property append child of now. And you can actually click on this, which will open up your actual JavaScript code and show you where that error is. And if you hover over the cross sign, you see what the error is, which is cannot read property of append child of null. So what this error is telling us is you're trying to append some child to something which is null. So why do we think this might be the case? Why are we getting some null object that we're trying to append to? So if we go back to our index.html, we notice, so we have this script, this JavaScript that we've included in our HTML page. And so let's imagine we are a browser and we're trying to load up this HTML page with this JavaScript. So I get this HTML page. And then before I'm done loading up my entire HTML page, I have this JavaScript, right? And then this JavaScript is accessing some elements that are in my HTML page, but then I haven't finished loading my entire page, right? So this might be a potential reason for why I get this error, right? It's like I'm saying from my document, get the body element, right? But right now my browser is telling me, say, I don't know what your body element is, right? Because I really haven't finished loading this document, so I don't yet have that body element that you're looking for. So this is why probably you've noticed with the previous work you've been doing, you have your script at the bottom. So let's say I could put my script here. And if I run this, so it actually gives me what I want. I have my DOM, and then I have my CS50 is awesome, and it runs, right? So now I have this DOM, this particular document has been loaded. The different elements that I have in there have been added to my DOM, right? And so now when my sourceman tries to access some element already in my DOM, defined in my DOM, it now doesn't throw an error. So one other way we can deal with this is I can still have it there. And then I can use one method provided to us by the window object, which is you can define a function and say, I only want to load this function when my page is actually done loading, right? So in this case, I'm going to call window.onload and say, so what window.onload means is simply say, when I'm finished loading my entire window, I can define some anonymous function, right? So we can have it there. Let's indent that. And then close this. So when we save this too, sorry, excuse me. Okay, so when we save this, we notice it runs without an error, right? Which is, of course, as explained. This is now executing after my entire window is actually loaded. So when I try to access my document.body, we want to return a null. It actually returns the element in my DOM. Okay, so those are some basic things, right? Then instead, also wanted us to look a bit into document.getElementById by ID and document.querySelector and selector O. So let's add some more things in my HTML, right? So let's say I had some paragraph. Let this paragraph be 1. And then 2 can have. OK. So I've added some new paragraphs, which really are just numbers. So let me try to minimize this. OK, so I have these numbers. And then let's say I now wanted to, say, modify or get some number, or get some paragraph from my HTML page, right? So one way of doing this is using my document.querySelector. OK. And then let result equals that. And then let's log this result. OK, so if I save this and run this, we can see what happens, right? So in this case, command save, and then so I can go to my console and see what I'm actually printing out. So in this case, I have this paragraph. So I documented querySelector P, right? So in this case, what this does is it's going to go into my DOM, select any element that has the P tag in it, and then I finally print it out, right? So it prints out the entire thing, which is that. So one thing that you notice is I actually defined a bunch of paragraphs. So I actually have 3 paragraphs. So I have 3 P tags in my DOM. But then what document.querySelector does is it's going to get the first matching element with the selector I have put here, right? And then so let's say I just wanted to I wanted to select this P with the 1, right? One way to go about this is I can assign an ID, right? And say, let this have an ID of P1, right? And then just so you can look at the different flavors of this, let's also have a class definition. Let's say this is class P2, right? And so if we remember in CSS, if I had like some CSS file that I've created, then I want to assign attributes to some element based on an ID, I would use a pound sign. So I would add like a pound in front of that, saying this is actually an element and not some, this is actually an ID and not some element tag. So in this case, the ID I used here was P1. So I can add it there. And so we notice, so it comes here, so I actually have the ID P1 and the content in it, right? And so let's say we can do something more, right? We can say, let's change the content of this paragraph. So this paragraph just has 1. And let's say I wanted to change it to result dot inner HTML, and I can say CS50 is great. And if I save this, so you notice my P1 now changes to that, right? So I had done something else. So I also added a class here, right? Now, let's say you don't want to select an element based on its ID or its tag. You want to select this element based on its class, right? So again, like we had in CSS, if you wanted to select an element based on its, so let's call this result 2. If you wanted to select something based on its class, instead of you having the pound sign, you'd have the dot, right? In this case, my class name is P2. right? So if I print my result 2, and I save this, so we notice in our console what we get printed out is my result P2. And then we have, so this is selector, document.query selector, and then we just do one last example of selector O, and say, let's say in this case, I wanted to return all my P tags, like every single element I have in my DOM with the tag P, right? So the thing I could use is I can use my document.query selector O, and then add my P tag there, right? So in this case, if I printed out my results and I say save, okay, so what you notice is we return some node list, right? So in this case, if we expand this, oops, too much expanded. Okay, so I have my P with ID P1, and then I have my P with class P2, and then I have my other Ps, right? So, okay, and we can look at the contents too. Okay. Okay. So unfortunately, this doesn't give me the content that I was looking for. It has got too much, but you can probably scroll through to see which P tag each of them relates to, right? But basically, so what document.query selector does is it is going to select all my P tags, and then it's going to return a list. So in this case, it's going to return an array of all the different P tags that I have in my DOM object. Okay, so probably won't go so much into DOM manipulation. We have covered a lot of that in class already. So I'll move on to the next part of this seminar. And okay, so finally, I want us to look at single-threaded asynchronous. Right, so when I asked the question, what is JavaScript? So I mentioned single-threaded asynchronous language, and like I said, I didn't go into detail then. We'd come to it, and now we have come to it. And so now the question is, what does it mean when someone says JavaScript is single-threaded? What does it mean when someone says JavaScript is an asynchronous language? Right? Okay. So in plain, simple words, right? So what does it mean for JavaScript is single-threaded? That means JavaScript in its runtime can only do one thing at a time, right? So what does it mean, really? So I'll give an example of humans, right? So humans are multi-threaded machines, if I should put it that way, in that you can say, I can talk on the phone and run. I can listen to something and work on my laptop, right? And so I am performing more than one task. I have the ability to perform more than one task at any given time, right? But then with JavaScript, it just can't do that. Like I can perform a network call in JavaScript and be doing some algebra calculations all at the same time. With JavaScript, when it executes in its runtime is when you give it a list of tasks to do, it is going to go over each task one at a time, right? So this is probably different from some languages that we're familiar with. For example, Python. Python is a multi-threaded language, which is it can multitask. It can do many things at one time, which is a useful feature because sometimes you might have something that takes long on a network, and you do not want that to store every other thing that you want to execute in your code. Right? Okay. So another like perception of it. So what does it mean to be single-threaded? You also find many people say this, which is JavaScript has a single CoStock. Right? And so we'll look into what really is a CoStock. Right? So have a simple definition for it, which is a CoStock is data structure that is going to record where we are in the program. Right? So I would put up this diagram, and we probably might have looked at this when we looked at our memory management inside our computers. So here we have the JavaScript environment, right? So we have the JavaScript runtime engine, which is really where my JavaScript code is executed. So in my runtime engine, I have the heap where memory allocation is going to take place, and I have the stack, right? So in my stack, I have a list of functions, and how the stack acts is that whenever I call a function is going to be popped onto the stack. And the function is only popped off the stack when my function actually returns, right? And so I have an example of this, and we'll kind of like see that in action. And then the whole JavaScript environment is not just made of the JavaScript runtime engine, right? So you have some other features that are added to this environment. You have things like web APIs, and then you have the event loop and the callback queue. And again, we're going to come back to this. So, excuse me. Okay. So, like I mentioned, JavaScript only has one single CoStock, right? So it only has like one single thread where it's going to be popping off and adding functions onto. So everything is going to be happening like synchronously, right? Like one at a time. So in this case, I have 3 functions onto my stack. So I have main, I have show text, set timeout. Later on, we'll see actually once they're on that stack. But then if I have defined a bunch of functions, they all go into my stack, and then JavaScript is just going to execute one function at a time. So I said this might be problematic if you have something that goes on for a long time, because it is going to block everything else from happening. And if this was, say, in your web browser, and you have using JavaScript, you define some function that blocks out every other JavaScript code, that would provide bad user experience in that every other thing that the user can do in your browser will be stopped until that one function that's really slow finally completes, and then other features can actually be accessed. So the question is, how does JavaScript manage to get around this, right? And so now this brings us to JavaScript being an asynchronous language, right? Which is, like I mentioned, your JavaScript runtime, where your JavaScript code is actually going to be executed, can only do one thing at a time. But then because your browsers add these extra features, such as your web APIs, your event loop, your JavaScript can do other things, right? And then we'll see why. So we'll come back to this, and then I'll give an example of why the web API helps us. OK. So again, so open up this example, and then I found this nice visualizer for the JavaScript environment, and I'll use this. Right? OK. So let's see. OK, so firstly, I want us to visualize the CoStock, right? Like, what really is a CoStock, and what does it mean to to put a function on it and pop a function off? So if I run this, right? So what we see is I have my, we'll pause this here. OK. So what we see is, so the highlighted means the functions that are being executed. So here I have this function at the top, which cannot be seen, unfortunately, because of that. So I have a function foo, which returns another function bar, which returns bar1, which returns another function, returns another function, all the way up to bar z, which is going to, sorry, OK. So all the way up to bar z, which is finally going to print out some high statement, right, and then finally return. And so this function, so I have defined this function, and then among these functions, right, you have this main function, which is way at the bottom. Then main calls the function foo, and then after the function foo has returned, main is finally going to return some 3 + 5 value. And so the first function to be called here, so notice all these are just function definitions. I haven't yet called any function except within the function, within functions themselves. But then the first function that I'm going to call here is my main function, right? So main, so console.log is going to call main, right? and then main will execute this. It's going to call foo, and then foo is going to start calling these other functions, right? And so this is what we notice happening, right? So as each function is called, it's going to be popped. Okay. So as each function is called, it's going to be popped onto the stack. And so the stack just keeps building, just keeps growing and growing and growing until the final function returns. So in this case, barz returns by console.log n high, right? And then once barz returns, then the other function. So once barz returns, then barz is finally popped off the stack, and then the other functions can now get popped off onto the stack. So if I do this, so you notice now my stack starts decreasing, right? So this is like what's happening in my JavaScript runtime, where I'm just having functions pile up, right? Okay. Now, I prepared an example to kind of simulate what I mean by if you have one function that's blocking everything else on your CoStock and what that would imply. So, so let's open up an example. So I have another page, which is just my async page. So it has, so in this case, I've linked the first JavaScript file that I have here. And so in this JavaScript file, we see it does the first thing, which is it prints out I'm starting, then enters this while loop, which goes on. And then this while loop just prints out I'm second a couple of times. And then when that while loop is done, prints out console.log, right? So if we run this in here, so okay, so it's already been run. But let's see what's happening in the console, right? So let's go in. OK, so what we notice is I start with I'm starting. Then I am the second that's being printed out. And then I am the last is now starts waiting, right? So it will not print out until I am done with my while loop, right? So say in this case you had like some other JavaScript functionality beneath this, right? What that means is everything that you have occurring after your while loop is now just going to stall and just wait for you to finish printing out this while loop, right? So of course this is not a real life kind of scenario, because I think, I mean, unless otherwise someone wouldn't really want to print out that statement forever, right? But this is just to show, say you can have some things like this that are in your code and then would prevent other things from running. So I keep on giving an example of network calls just because network calls, such as say me getting something from some API, would take a long time to execute. So let's say you had a network call here, which takes forever. That means every other thing that you want to do would have to wait for that network call to complete, and then you do it, right? But then I said JavaScript has found a way to get around this, to execute things more than once using asynchronous functions. And so we're going to open one, right? So in this second example, I have replaced that while loop that I had with a set timeout function. So a set timeout is something provided us through the web APIs. And what set timeout does, so set timeout accepts a function, a callback function, and your delay value. So in this case, what it means to be a callback function is I am this function that's going to be called when this thing is finished with what it's supposed to do, right? So let me write it out as it would, right? So I'm supposed to have a function delay, right? So the main object of set timeout is it's going to create some delay in what you're doing, right? And then the purpose of the callback function is it's going to stipulate what is going to happen when your set timeout has actually finished. So in this case, when your time has run out, right? So in this case, I have set a time of 10,000, right? And what I'm saying is create this delay of 10,000, and then when you're finally done, I want you to execute this function, which is just console.log n, the callback function, right? So let's see how this works. So if I run this, so I'll go into the index of this, and let's link instead my async. Okay. That is strange. Okay. Okay. So let's refresh that and see what happens. And okay. So it's taking a while. Probably let me reduce the time here to maybe that much. Okay, so it's taking a while, but we see what's happening, right? So in this case, the first thing that I do is I call I'm starting, then I put a timeout, and then I finally call the console.log and the last function, right? But then if we see the order in which they executed, we notice the first thing that's executed is I'm starting, and then finally I'm the last function. Then I'm the last function, and then finally I'm the callback, right? So set timeout is an asynchronous function, right? Which is really going to say, I will, so you're going to call set timeout, right? And then set timeout is going to run in its web API, right? And then when it starts running in its web API, I will not have set timeout on my CoStock, right? And so what does it mean to push off set timeout on the CoStock? That means I can add my console.log onto the CoStock and actually execute it, right? So notice, so if I refresh this, right, in that I don't have to wait for set timeout to execute for me to actually continue executing my other code, right? And so this is how JavaScript manages to get around its, like, deal with its single-threaded nature by creating these asynchronous functions, which do not block other functions from executing, right? But simply are going to execute when I'm done, right? Now, so in understanding the synchronous functions, I think it's best to actually see how this happens. Again, we'll go back to this visualizer here. And okay, so let's get rid of this previous example. And I'll start with the first one. Okay, so start with Nodejs. And if I have it in here, so this is Nodejs, and you notice what Nodejs is doing, right? Which is so the first one has already executed, and now I'm just like stuck in this while loop, which is running and running until it's done. And then when it's finally done, then I execute console.log, right? But then let's see how this differs from how my asynchronous function is going to act. So I paste this in this tool, and then I'm going to run this, right? And so, okay, so we notice something happening, right? Which is, okay, so what we notice is when I start this, so I'll make this a bit slower so that you see. So what we notice is when I start this, my first function, console.log, is pushed onto my stack. It executes. Then I get my second function, set timeout. But then it's a web API, so it's pushed off the stack. Then it goes into my web API. So since it's pushed off the stack, I am able, it's too fast too, so I'll probably use a pause. So I said I have console.log pushed off the stack, then set timeout, which is some web API function. So here it's pushed off, right, the stack. And so because it's pushed off the stack, it's now being executed here in my web APIs. I can have my other function here, which is beneath my set timeout, come onto my stack. So that means I can now execute this console.log function. And then now when you have this set timeout, so set timeout is working in your web API, you do not want your web APIs to immediately modify your code or just immediately push code onto your stack in the middle of your code running, right? So why might that be problematic, right? Let's say this was like some function that, so I already have some logical flow of my work, right? And if my web APIs could randomly push stuff back onto the stack, it probably won't be as consistent, right? Like the flow of your work would not be as smooth as you probably would want it to be. So instead of your web APIs randomly pushing stuff back onto your stack, you have this callback queue, which is here beneath at the bottom of the page, right? And then what this callback queue does is it has this event loop. So the event loop, so when the web API is done running what it's supposed to do, it pushes the particular callback function that you want executed at the end into the callback queue. And then the event loop monitors this callback queue, saying, when my stack is empty, right, that means when I have finished running all my functions in my stack, I am going to get the first function in my callback queue and put it onto my stack, and then it's going to be executed, right? So we see how this works. And then summary running. So set timeout goes into my stack, goes to web API, the last function executes, then callback goes into callback queue, it's pushed onto the stack, it executes, and then I'm done, right? And so this is like the basic flow of your asynchronous functions, right? And this is how they manage. This is how they enable us to do other things whilst they are running. Somewhere in the background, but not really in the background. But yeah. Okay. So now, so we've noticed, say, my set timeout is going to run and will only like go back onto, will be only executed. In this case, the callback function will only execute once I'm done doing everything. In this case, executing every other function in my CoStock. But there might be instances where you want to stipulate that I want this particular function to execute only after my synchronous function is done executing, right? So in this case, say I performed a network call to my Google search, right? And all I want to do is give my user back the list of foods based on their preferences, right? So I do not want to display something before I actually get back my response from Google. So I would want to have a way to stipulate, say, when I do my search, I only want my display function to execute after my search, right? And so this is now where the issue of async await and promises come in, right? So I'll open up an example. Okay, so here you have kind of an example just to kind of like show what I was talking about, which is, so let's go to this and let this be my promise one. Right? So if I open up my HTML page, and okay, so I've linked that there. And okay, this is my sync page. Okay, so I have my first promise here, which is, so in this case, my promise, so just give me a moment. Okay, so in this case, I have a promise. I have a promise example where we start off with the example that I gave, where I have a function, except I want this particular, in this case, it's not a function, it's some line of code, and I want this line of code to execute when my set timeout is actually done, right? So in this case, I set x to be the value that's going to be returned once I finish running my set timeout. And then I let my y equals to, the product of x times 10. So one potential problem that might arise from here is, so we notice it says set timeout is going to run in the background, and then everything else is going to run as normal. But then we notice we're using x, which is the value returned from set timeout. So if set timeout happened to run for a long time, which it will do in this case, and then I code my y on x, right? So the most likely thing is I would get an error. And let's see if we can actually see that. And so, don't know. Okay. Okay, so the surprising thing is actually gives me okay. And okay, so I'm wondering why it's giving me some random value, which it should not be doing, right? But I'll instead run this in, okay, so like I said previously, I had that we can run our JavaScript outside our browser using Nodejs. So if you wanted to run JavaScript outside your browser, you'd have to install Nodejs. So I have it installed on my computer. And I think for now we'll use it because I cannot seem to find why my browser gives me some random value. All right. So in this case, I want to run promise 1. OK, so it gives me what I'm expecting. Right. So at the bottom of my terminal here, so I call Node, and I say, Node, can you run this particular JavaScript file where I'm running promise 1. So promise 1 first prints out I'm starting, then calls this function x, and then multiplies x times 10, stores it in y, and then prints out y. One problem that we notice is it starts off I'm starting, then prints out none, which is like not a number, and then ends, right? So why does it do that? So like I mentioned, you are using x before most likely your set timeout hasn't actually finished executing. So when your JS runtime, in this case, execute this line of code, it doesn't know what x is. And so it just returns not a number, right? And so then I mentioned promises, right, and async await. So here I have described, given a solution for how you'd get around this problem of I want to set some code to execute after this has finished. So this was the function, the set timeout function that we had before, except now I've defined it inside a promise. So basic syntax for a promise is you have a function, and then it has the parameters resolve, reject, right? And then what promise does is it's going to execute a particular function, and then it will either resolve, which would mean to give that value. So resolve in this case is my callback value. So if my set timeout is done, it's going to call this function, and then it's going to call resolve, right? So resolve means my promise has finished executing, and then I'm passing in a value, so that's the value it's going to yield. And so if I define this promise, and then I wanted to use it, right? So instead of me just using x randomly, so I define an async function. So in this case, I am defining an asynchronous function. So why I do this is asynchronous functions come with this key word here, which is await. And then what await does is it's going to pause my synchronous function and then wait for a promise to finish executing. And then after this particular promise is done, in this case, after my promise resolves, it's going to continue executing its code. So I first await the value of my promise. Then when my promise is done, I call y x times 5, and then I console.log y, right? And so if I code my function, so in this case, I have mount. So this is in promise 2. So if I execute promise 2, so I get the value that I'm looking for, right, which is I'm starting, then it actually executes 25. So, yeah. So now this is using async functions, and then one thing that has also been added is, aside from using async await function, I can also use .then. So I'm going to use show another promise example where instead of me awaiting a promise, I'm going to say execute this async function in this promise, like get this promise value. Then when the promise is done, execute this function, right? So I defined, so it's the same promise from before. And then I define a new, so I call my promise here and say perform this promise. Like when my promise has finally resolved, then execute this function, right? So I have a function which takes in x, right? So whichever value is returned from my promise is assigned to this particular x parameter. And then I can finally multiply my x times 5, and then I can console.log y. And so if I executed this in my node, I still get the same thing, right? So this is really doing the same thing as my sync awaits, right? So might depend on like preference, right? Or you might go into details and actually talk about what really is the difference between using .then and a sync await. But yeah, but this is basically how you can handle promises and how you can stipulate when a particular set of code is going to execute with regards to an asynchronous function, where in our case, our synchronous function is set timeout, right? Okay, and then probably one thing that would want to do from what we learned previously, which is I can actually shorten my function here and say, instead of me having that, I can simply set it to do that and save. And then if I run this, I still get the same thing. Okay. So we'll just like summarize what we just did, which is what happens when a function provided by some web API is called. In this case, I stated web API, but let's say my synchronous function is called, right? So I'm going to have that asynchronous function code. In this case, for example, set timeout. And then that function will push off the stack. Then it's going to be executed somewhere else. And then, oops, sorry. OK, and then when it's done, my function is going to be added back to my task queue. And then my event loop, which monitors a task queue, is going to push my function back into the stack when done, right? And so yeah. Then, of course, promises a sync await, which we just looked at. And so this is probably a lot to take in. And I will say probably working with the visualizer, seeing how exactly a synchronous function works, when getting more practice into promises and dealing with those asynchronous functions is probably like a good way to get a handle of this. And this is why probably like JavaScript becomes like tricky to learn, just because of its single-threaded nature and how you have to deal with these like async functions, right? But I think with more practice, you kind of get a handle of them. And I hope this gave you like some place to start. And that's it for this seminar.